Suppose a treadmill has an average acceleration of 4.7 times 10 to a negative third power meters over second square. How much does its speed change after 5 minutes? And if the treadmill's initial speed is 1.7 meters per second, what is its final speed be? Okay, first of all, we need to focus on the topic. Okay, the topic is average acceleration, which means that the equation that we're going to be using is the equation for average acceleration. So, because this is the topic, okay, I'm going to focus on the equation. The equation says acceleration and average is equal to the average velocity divided by delta t. Okay, that is the equation that we need to focus. Now, what is the problem given me here? What is the problem given me here? It's given
Average acceleration.
average acceleration and okay, so AVG is equal to 4.7 times 10 to a negative third power meters over second squared. Okay. And in part A, okay. In part A, it says how much does its speed change after 5 minutes? So they're asking me about this, the change in speed. Okay. Speed change is equal to change in speed. And every time you see change, the word change represents a subtraction, okay? Change is represented by the Greek letter delta, and that means subtraction. As we're talking about change in speed, we're going to be talking about change in velocity, okay? The change in velocity. So this is going to be the change in velocity that is average. That is what I'm going to look for. So this is my unknown. Now, what else the problem gives me in this question? It says after 5 minutes, okay? So the time, delta t, it says 5 minutes. So what you have to know so far is that everything that is not given in meters or in seconds, okay, it should be converted. So in the first place, what we're going to be doing here is converting from minutes to seconds, okay? So this will be very simple. 5 minutes times and the conversion factor, that is that in 1 minute you have how many seconds?
60 seconds.
60 seconds. So in total I have 300 seconds, okay? So this is the delta t for part A. So I need to find delta VEG. Actually, this equation, sorry, I didn't write it. But the equation actually has a delta symbol in it. Okay? So you're isolating, you will need to find VAVG. So the solution will be write the main equation and isolate it. Average acceleration is equal the change in velocity divided by sorry, delta t. What is VAVG? Take a look. If I want to isolate, I need to take this away, okay? And this time right here is making a division. So when you move it to the other side of the equation, it's going to be doing the opposite operation, which is multiplication, okay? So this is going to be delta t times average acceleration equals delta velocity, okay? Now, this is your equation already isolated for delta V. Now, I don't like the way it looks, so I'm just going to change the position of it because I always like to have I like to have it in the left. So I'm just going to write it. That's a personal choice. And I will substitute by the givens. Delta t, that is 300 seconds. And acceleration, that is given in the problem as 4.7 times 10 to a negative third power meters over second square. How much is this? How much is this?
1.31 meters squared.
1.41. Now take a look here. Take a look. I always do this because I want you to see how I get the units. This is given in meters over second square. Second square is equal to seconds times seconds. You learned that in math, okay? So imagine that here you have instead seconds times seconds, and you are multiplying times seconds, which means one of them is going to be eliminated. So what are you going to have in the end? You're going to have that 1.41. You're going to have meters above and seconds below. So the answer is going to be meters over second. Now let's go back to the problem and let's look for the part B. It says, if the treadmill's initial speed is 1.7 meters per second, what will its final speed be? So we go to part B, okay, and I'm gonna write the information provided by the question. So in part B, it says, if the initial speed is 1.7 meters over second, what is the final velocity? Okay, so in this part, what you have to know is what equation involves everything, okay? Initial and final velocity. So I gave you an equation that says delta V, well, it doesn't say it, but it's here in the, it's a definition. Let me just look for it so you can see it. Okay. I'm just gonna copy and paste. Sorry for you to see. This is the definition of average acceleration. It says this is delta V divided by delta T. Now, the definition for delta V, okay, the definition for delta V is final condition of velocity minus the initial condition of velocity. If you want to know what delta in any other unit is, for example, time, delta time is going to be the final time minus the initial condition of the time. Remember that delta always means final minus initial. Could be temperature, could be velocity, could be acceleration, could be time, could be whatever. Delta or change, that delta represents change, is always going to be calculated like that, final minus initial. So applying this, we know that the definition for delta V or delta V average is equal to final condition of velocity minus the initial condition of velocity. You know this because you got it from the step before. You know the initial velocity because it's given in the part B, and you are looking for the final velocity, which means that you need to isolate. So to isolate, I need to get rid of this initial velocity because it's there, and I want to put it apart because it's bothering me. Okay, it's bothering me. So if I need to isolate this initial velocity, what operation is it doing? Addition, subtraction, multiplication, or division? What operation is it doing?
It's
Adding,
subtracting.
it is subtracting, okay? So it is subtracting. When you move it to the other side of the equation, we'll be doing addition, okay? So delta VAG plus initial velocity is going to be equal to my final velocity. Again, I arrange because it is my personal choice to have my unknown in the left, so I'm going to arrange it as final velocity equals delta V plus VI, initial velocity. I just plug in the givens, and I know that this is 1.41 meters over second plus initial velocity that is 1.7 meters over second. In total, I have 3.11 meters over second. Just 3.11. So as you can see, everything comes, even though this is not part of the main equation, I took it from the main equation for average velocity. Remember this. That's why I always write to you the main equation, because from there you can get a lot of things. Okay, this is the definition that I use. Average acceleration, that's the equation. Okay, but the definition that I use for delta V is right here. Okay, delta V equals final velocity minus initial velocity. If I talk to you about displacement, which is delta x, the equation is going to be the same, x final minus x initial. If I talk to you about delta t, it's going to be the same, final time minus initial time. If I talk to you about change in temperature, uppercase T is for temperature, not time, okay? Delta T, in this case uppercase, is going to be the final temperature minus initial temperature, and so on, okay? So remember this. Every delta that you see here represents a subtraction, okay, of final minus initial conditions. Xavier?
Miss, but well, it will be a very rare case that we have like did what? No, did no, yes, did no, I'm confusing. Okay, like X initial minus X final, something like that.
Mm, no, it's always final minus initial, okay? It's always final minus initial. But in this case, the isolation gave you a different thing, okay? The subtraction converts into an addition symbol. But just remember this, it's always the final minus the initial. But in the case that you need to isolate, okay, I can give it to you, okay, the isolations. I'm gonna erase this. In the case that a problem asks you about, well, final velocity, you have it over there, about the initial velocity, for example, you can take the same equation. Delta V equals final minus initial. You can isolate for the initial. So what I do to make it positive, I'm going to arrange it into the other side. It was subtracted, comes to add. So delta V plus VI equals VF, but I'm isolating VI, okay? Still I'm isolating, I haven't finished. So what I do from here is I'm going to move delta V. Delta V, what operation is doing there? Adding, subtracting, dividing, or multiplying?
Adding.
Is adding, okay? So when you move it to the other side of the equation, it's gonna be doing subtraction. So it's more about how you play with the formula, okay? So this BI is going to be equal to final minus delta V. So as you can see, from one equation, you can get that too. But delta is always going to be final minus initial. And I know that sometimes you want just to subtract, to do the subtraction in any way that you want it, okay? Because for example here, if I tell you, um, okay, so the initial time is at 2 seconds and the final time, for example, is at 5 seconds. Imagine this. If I told you the delta t means a change in time, what was the change in time? So apply your applying the logical side will be, okay, the difference in time is just 3 seconds. But sometimes when negative comes in, for example, the initial time is negative 2 seconds and the final time is negative 5 seconds, it's a lot more complicated. You cannot do it mentally. That's why I always apply the formula. So in this case, for delta t, I apply the formula. Sometimes you can do it mentally. Sometimes I really suggest, I really recommend you to do it the process. So the final time is minus 5 seconds, minus from the formula, and the initial time that is minus 2 seconds. Minus 5 seconds plus 2 seconds. So take a look, that the change in time here is different. There's a difference of a negative. That negative can make a huge difference in your answer. So always, even though if it's easier sometimes in the other way, try to respect the formula. Final minus initial, always like that. And if this gives you a negative symbol, respect the symbol. Freddy.
Miss, what you just done in time, the answer is -3, but you said that time can be negative.
No, that means that doesn't mean that I calculated the time. That means there's a change in time. Okay? That just means that for example, yeah, it doesn't make sense honestly. But in a graph, okay, in a graph, it could represent that it moved to the left. That is a different kind of thing that I'm working with right now. Imagine that this is the time, okay? And the time was here. Let me see, no, the final time was here in -5. And then you subtracted the initial time that was 2 seconds, okay, in negative. So as you can see, because the negative gives you the positive, you move 2 units to the right, okay? So even though the change in time is just 3 seconds, okay? Yes, it's just 3 seconds. The end point in your, imagine, you're not seeing it. I'm so dumb. Imagine that this is just a number line, okay? So this will be giving you the -3. I apply it for time, but call it temperature for -5 Celsius to -2 Celsius, something like that. Okay, it doesn't need to be precise. Yeah, it shows a terrible idea on the time. Call it velocity then. Initial velocity to be -5, final velocity to be -2, for example. What is delta V? Always final minus initial. V. -5 meters per second minus -2, sorry, -2 meters per second minus -5 meters over second. So this is going to give you actually a different answer because it shows differently. So this will be -2 meters over second plus 5 meters over second. And in this case, as you can see, the sign change to +3 meters over second. But if you do it like that, like what is the difference between -5 and -2? Or if you get this part incorrect, you're gonna have a different answer. So that's why I always tell you, respect the formula. The formula have a specific order, respect it, because from this you can get negative answers, okay? If you get negative answers, that can affect your answer, the total answer in the end. So yes, try to respect that. I have 4 minutes to explain any other doubt that you have in any other exercise.
In page 51, number
51,
3, exercise number 3.
51. Okay.
51. In the answers that you gave us, there is positive 19, and I got
You got
negative
the
19.
-18, right? Negative 18.
Negative 19.
Uh-huh.
Yeah.
Uh-huh. Yes, I know. I want to point out something, and that is one of the questions the other group had too. And this is actually more about how the question is made. Okay. So it says a car starts from rest and travels for 5 seconds with constant acceleration of -5, 1.5 meters per second squared. What is the final velocity of the car? How far does the car travel in this time interval? So take a look. The equation that you use, I hate the noise. The equation that you use for to calculate how far does the car travel is this one right here, right? Is this one. Which one is it? Okay, it's this one, right? That's the one you use. Is this the one you use?
Yes.
Okay. Okay. So take a look. This delta x in your equation means displacement. Displacement means change in position. Okay? So when I talk to you about displacement, this word exactly, displacement, means that you can write the symbols. Could either be positive, negative, south, west, north, etc. Okay? That means that displacement implies direction. In this case, the problem is not asking you about displacement. It's just asking you about how far the car travel, okay? How far? And by how far, it means distance. Displacement, as I told you in the beginning of my class, displacement is not the same as distance. Distance is just a number, okay? Just a number, which means no signs, no directions, okay? So when it talks to you about how far does the car travel, refers to distance, which means that it's not necessary you to write a symbol. Though that you got negative 19 doesn't mean that it's incorrect. Actually, it is correct. It just tells you that the direction of the car could be to the left, okay, or to the west or south, for example. These are directions that we know as negative. So if you got negative 19 meters, means that the car is traveling in that direction. That's all it means. So to make it positive, what you can do is erase the sign and put the direction in symbol like this, if you want, okay? If you want it to be positive. But as I told you, by the type of question, when it says how far, it's just distance, not displacement. Now, if the question